today was extra special because of it really tying the whole world together. You should be very, very proud, and I'm proud to be working with you on board the International Space Station. Thank you very much.
We've been making this program for like the past 3 months, working day and night, and I'm really happy that our efforts paid off at the very end. So I really appreciate JAXA for this amazing event and this amazing opportunity.
So I personally have developed a huge interest in robotics and space and things like that because of this competition. And it is not just about the technical stuff or programming, but also about teamwork. And also at the same time, I personally think that it wasn't just about competing, but also about learning new things along the way.
でまずね宇宙のシステム特有なんだけど、作った人から離れたところで動くっていうね、これが宇宙特有なんですよ。だからそのためには離れてるから何かあった時にすぐに修理に行けないとか変えるってことができなくて、もう動き始めたらもう手出せないっていうね、そういったところが題材になってるというところがまず面白いね。それがこのロボットプログラミングコンテストでも宇宙のシステムを扱うのと同じような感覚でシステムを作ってね、実験できるというこのところがまず一つ面白いですね。それからね、やっぱりこの国際大会になってるというところが面白いよね。日本代表を決めて、でアジアのいろんな国々の代表が出てきてね、これがお互い戦い合う。でそれはもしかしたら宇宙開発をそれほどやってない国もあるかもしれない。そういった国でも中の若手は非常にいいプログラムを作ってくるかもしれないと、そういったことで、切磋琢磨するね一つのいい場になると思うんで、そういった観点でも期待しています。
そうですね、これを通じてやっぱり自分も宇宙開発に携わることができる、宇宙というのは思ったよりも自分たちに身近なものなんだっていうところを感じてほしいなというふうに思います。子どもたちも実は宇宙は身近になっていて、自分たちはその、宇宙を使う能力を持っていて、そこで貢献できるっていうことを実は知らないだけでその素地は持っていると思うんですよ。で、そういう機会を今回この、プログラミングチャレンジで、皆さんに知っていただくことで、自分自身のその子どもたちの自分の将来のねその可能性に気がついてほしいと思いますし、次は自分も参加したいみたいなコメントもありましたから、それに触発されてさらに多くの若い人たちが参加をして、で日本の宇宙開発、世界の宇宙開発を引っ張っていくような人材になってほしいというふうに思います。
Hi everyone, my name is Naoko Yamazaki. I am a former JAXA astronaut and very happy to welcome you all to this second Kibo Robot Programming Challenge, Kibo-RPC, Programming Skills Round. I hope you will enjoy the round today. Well, let me introduce our commentators for the Programming Skills Round. Professor Shinichi Nakasuka, he is also an advisor of Kibo-RPC.
Hi, everyone. Good morning and good afternoon, everyone. My name is Shinichi Nakasuka, the professor of the Department of Aeronautics and Astronautics, University of Tokyo. I have been the advisor of this Kibo-RPC since initial, and today I will play a role of the commentator as well. I hope that your program can work very well. Okay, I am looking forward to seeing your performance. Thank you.
Thank you, Professor Nakasuka. Another commentator is astronaut Kimiya Yui.
Hello everyone, my name is Kimiya Yui. I'm a JAXA astronaut and one of the commentators for this event. I'm really looking forward to seeing the result of your simulation. Thank you very much.
Thank you, Kimiya-san. Today, as you see on the screen, we will introduce the Kibo Robot Programming Challenge, followed by a self-introduction of all delegates, the Kibo-RPC rules, and then competition. We will watch simulations of your programs to decide the team with the best programming skills. The competition will end after the closing remarks from our advisor. Now I'd like to introduce about the Kibo Robot Programming Challenge. The Kibo-RPC is a competition and an educational program in which students solve various problems by programming free-flying robots such as Astrobee and Interpol in the International Space Station. The program is held under the cooperation of JAXA and NASA, and Asian beneficial collaboration through Kibo utilization. Students up to graduate school can participate in the Kibo-RPC. A team is comprised of more than 3 members. The international competition is for students in the Asia-Pacific region. Each participating country and region held the preliminary rounds last week and today for Japan. The winning teams of preliminary rounds compete for their programming skills in this programming skills round in the simulation environment. After this competition, they advance into the final round to compete in the ISS. Now I'd like to introduce the honorable finalists in alphabetical order by the country and region. Due to the COVID situation, the finalists are participating remotely. Let's welcome the first team, Dream Rover from Australia.
Hello, thank you. We are the Dream Rovers of Australia. We have 6 members in our team: Douglas, Albert, Josh, Annabelle, and myself, and Jai, of course. Our obsession with robotics led us to programming, which then brought this team together to work together on this project. My name is Ethan Lee. I am the team leader of Dream Rover. I am 14 years of age and in year 9 in Sydney Boys High School. My hobbies include coding, robotics, chess, and golf. Douglas comes from Kalara High School and is 15 years of age. He has a lot of experience in programming. The programming languages he codes include JavaScript, Python, and C++. Joshua Lee is 12 years old from Sydney Boys High School. He recently participated in the VEX Worlds competition and managed to place first. Annabelle was in the same VEX championship team as Joshua, and she enjoys programming along with robotics. Albert Zong is 13 years of age and he goes to the Scots College. His hobbies include reading, writing, and coding. Jai is 15 years old and in year 10 at Knox Grammar School. He's interested in coding and is obsessed with robotics. Thanks, that's all.
Well, thank you and good luck, Dream Rover. And let's welcome the next team, Enigma Systems from People's Republic of Bangladesh. Hello, I'm sorry you're muted.
Oh, sorry, I apologize.
Oh, no problem.
So, okay, I'll start again. So, we are Enigma Systems from Bangladesh, and I am Mohammad Hasibul Islam, the team lead of Enigma Systems. I am currently a student of BRAC University, Bangladesh, and some of my interests include programming, robotics, and embedded systems. So, all the Bangladeshi teams, including Enigma Systems, are students of STEMX 365 by Mizanul Chaudhuri sir and Saba Jaminapu. And without the help and collaboration of STEMX 365, I don't think Bangladesh will be able to join this competition. So I'd like to thank STEMX 365, JAXA, and all the Bangladeshi teams participating in this competition. Furthermore, all the team members of Enigma Systems are members of the Mars Rover project of BRAC University, participating in the University Rover Challenge. So some of my hobbies include playing the guitar, playing computer games, listening to audiobooks, and photography. So best wishes to all the teams participating in this competition. And now Rajan bin Issa will be introducing himself. Thank you.
Hello everyone, I am Rajan bin Issa, recently graduated from Bragg University in Computer Science and Engineering department. I am currently working as a deep learning engineer. I was involved in Bragg Onnasha ground station, which was a nano satellite with a collaboration between Bragg and Kyotech University, Japan. So my team was also among the global top 4 teams in NASA Space Challenge 2008. My field of interest is space robotics as well as artificial intelligence and AI. Traveling, watching movies, listening to music, playing video games are some of my activities that I like to do in my leisure time. Thank you everyone, all the best wishes for the finalist teams. So now Rafi will talk about him.
Okay. Hello everyone, I am Suhail Haprofi, currently in my junior year at Bragg University. I love working on artificial intelligence and as well as on robotics. And besides my studies, I contribute in designing and developing the control system of our Mars rover. At the moment, I am doing my bachelor thesis on autonomous systems. And apart from this, I have another research ongoing in the field of computer vision. Reading books, watching movies, playing football are some of the activities that I like to do in my leisure. I wish all the best to the participants. Thank you. Now, Abrar Mustaqim Taki will be continuing.
Hello, my name is Assam Abrar Mustaqim Taki. I am studying computer science and engineering at Bragg University. Along with Mongol Tori, I am also working on the Bragg University Underwater Autonomous Vehicle project, which is known as Bragg Dubori. My fields of interest are robotics and machine learning. Thank you. Next, my friend Dhruvo will talk.
Assalamu alaikum. I'm Tassanul Haq Dhruvo and I'm from Bragg University. This is my 5th semester and my field of interest is computer programming and robotics. And I wish best of luck to the rest of the team. Thank you.
Well, thank you and best wishes, Enigma Systems. The next team is Cepheus 2 from Republic of Indonesia.
Thank you. Hello everyone, good afternoon from Indonesia. We are excited to meet you all. I'm Neil, 22 years old and the leader of the Cepheus 2 team. Currently, I'm in my final year studying electronic engineering. I'm representing Indonesia at the second Kibo-RPC along with 4 other members. We are from the same university, Yogyakarta State University, located in Yogyakarta, Java Island. Let me introduce my team members. The first one is Faris. He is 21 years old, currently studying mechatronic engineering. He has a deep interest in programming and robotics. The second member is Lexi, age 20. He is taking an electronic engineering major. The next member is Fikrian. He is 19 years old and he is majoring in mechatronic engineering. And the final member is Fahriza. Fahriza is the youngest member that currently focuses on learning electrical engineering in his sophomore year. Also, we would like to thank Lapan and JAXA for organizing the event and giving us a good opportunity to participate in the programming skill round. It is an honor to be here. We have put intensive effort and mindful preparation during the development of the program. Therefore, we hope our program could deliver significant performance in this round. Thank you. Arigato.
Well, thank you and hope you will enjoy it, Cepheus 2 teams. And the next team is Cosmic Jellyfish from Japan.
Hello, we are Cosmic Jellyfish. We are undergraduate and graduate students doing research in Miyazaki Laboratory of Nihon University. We are studying the structure of large space structures. We participate in Kibo-RPC as a part of our class. Although we didn't have much knowledge of programming, we were able to participate in Kibo-RPC by running many simulations together. I would like to do my best to carry the thoughts of other Japanese teams. That's all. Thank you.
Well, thank you and good luck, Jellyfish, Cosmic Jellyfish. Well, let's welcome the next team is Lemon Tree from Malaysia.
Hello everyone, we are from Malaysia. My name is Sikjanda, the team leader for Lemon Trees. For our team, we consist 5 members, included me. We are all from University Technology of Malaysia. And first, I would like to introduce my teammates. Chong Chen Lee is currently second-year student studying software engineers. And next is Taiwan Jun. He also second-year student studying software engineering. Followed by Hollis. He's currently major at physics. Okay, the last one is Fan Willie. He's currently studying mechatronics engineering. And I wish all the best for other teams. Thank you.
Well, thank you, Lemon Tree. Hope you will enjoy it. So the next, so we are preparing for the Zoom for the next team. So before the connection, we'd like to ask some questions to astronaut Yui, if you don't mind. Mm-hmm. Okay, so I think the finalists are so interested in ISS and robotics operation. So Kimiya-san, I remember you operated the ISS robotic arm to capture the cargo transfer vehicle. Mm-hmm. So how was it?
Yeah, that was so exciting actually, and a lot of responsibility. So a little bit nervous, but because of the lot of training, it went well. So I was so relieved. Yes, it was fun actually. Yeah.
Yeah, I can tell, the preparation means a lot.
Yeah.
And today's finalists should have made us so many preparation to come to this, programming skills round. So good news, Zoom is ready now. So I'd like to move on to the next team, Elon's Fangirls from New Zealand.
Hi everyone, I'm Nicholas and I'm the team leader for Elon's Fangirls from New Zealand. I'm honored to speak on behalf of the rest of my team, the present in this call, Jack Breen, Remus Courtney, Stephanie Southman, and Amanda Lee. We're a mix of second, third, fourth, and fifth year undergraduate students studying engineering science, software, mechanical, mechatronics, biomedical engineering, computer science, physics, and more at the University of Auckland. We all have a deep passion for space exploration, robots, and building cool stuff, which is what brought us all together for the second Kibo Robot Programming Challenge. We're excited to represent New Zealand in the programming skills round, and best of luck to all the teams.
Well, thank you very much, Elon's Fangirls, and good luck. So the next team is Descendants of the Sun from Republic of Singapore.
Hello everyone, I'm An, the firstborn of the Descendants of the Sun. So I'm currently a computer science student and an active member of our school's club, Student for Exploration and Development of Space. So our team are based in Nanyang Technological University, Singapore, and our team members are from diverse disciplines and backgrounds, hailing from Indonesia, Vietnam, India, and Singapore. So on my left, I have Andrew. He's 21 and majoring in electrical and electronic engineering in NTU. He's interested in machine learning, computer vision, and robotics. On my right, I have Henry, who's a current student in computer science in the second year. He's interested in machine learning and its application. And through this competition, he wants to have a chance to learn more about space and robotics. Below, we have Jainil and Cheng Sing. Jainil is also 21 years old and incoming final year student at mechanical engineering. And he's specializing in robotics for his degree. And this competition appeals to him with a chance to gain experience with robotics in space. Cheng Sing is currently an aerospace student in the second year. She's interested in all things space and joined this competition to learn more about how controls in zero-G works and brush up the coding skills. So United under the sun and by an interest in space technologies, we would love to join you all in this learning journey to the International Space Station. Thank you.
Well, thank you, Descendants of the Sun, and the best wishes. Let's welcome the next team, Gemini, Paraguay, Taiwan, from Taiwan.
Genes, team leader of Gemini, Paraguay, Taiwan, representing team of Taiwan in the second Kibo-Robot Programming Challenge. I'm 27 years old, and I'm pursuing a master's degree in space science, systems, and engineering at National Central University in Taoyuan. Gemini, Paraguay, Taiwan was formed after an invitation extended to the Paraguayan Space Agency by the National Space Program Organization, the space agency from Taiwan. Then, the Paraguayan Space Agency decided to extend this invitation to Taiwan Paraguay Polytechnic University, which they gladly accepted. My teammates are all currently studying at the National Taiwan University of Science and Technology in Taipei, Taiwan. Sebastián Zamudio is 21 years old and is an electromechanical engineering undergraduate student. Alejandro Molinas, 20 years of age, also an electromechanical engineering undergraduate student. Pamela Aguirre, 20 years of age, industrial engineering undergraduate student. Gilberto Penayo, 19 years of age, computer science undergraduate student, and William Ecker-Leben, 21 years old, computer science undergraduate student. We decided to name our team Gemini Paraguay Taiwan as a tribute to one of NASA's first mission, Gemini. As Gemini Paraguay Taiwan is undoubtedly one of the first missions by NSPO and AEB. We'd like to thank JATSA for this opportunity given to students all around the world to engage in space science and furthermore engage in cooperation and friendship. Good luck to all our competitors. Thank you everyone again. Arigato.
Thank you, Gemini, Paraguay, Taiwan, and good luck. The next team is Indentation Error from Kingdom of Thailand. Please, you are muted. Okay, so.
Hi, my name is
Okay, great.
Our team consists of 3 people, me, Setapan, and Ganupo. We are all high school students from Assumption College, Hungary. So we decided to name our team Indentation Error because it is the error message in Python and we use Python a lot before. So we are all interested in programming and robotics. Thank you all for our team.
Thank you, Indentation Error. And thank you, all the 9 teams. Actually, I'm impressed each naming of the team. And I wish you all the best. Now we are going to watch a video on the rules.
We would like to explain the rule of the second Kibo-Robot Programming Challenge, the Programming Skills Round. In the second Kibo-RPC, Astrobee is used as a programmable robot. Astrobee is NASA's free-flying robot in the International Space Station. Astrobee has a wide-angle camera called NavCam. Using this camera and inertial measurement unit, Astrobee estimates self-position to fly autonomously. Also, laser pointer is used in the game. The participants created their programs to control Astrobee and compete for their programming skills utilizing such functions. This is the game story of the second Kibo-RPC. The ISS air leak that occurred in 2020 has been repaired by talented programmers in Asia. Every day back on the ISS. However, because only an emergency measure was taken, the air leak recurred in 2021. The location of the leak has already been identified. Asian programmers do a complete repair and report completion of the mission to the astronauts. In this programming skills round, the participants' programs was run in the simulator JAXA and NASA developed. All teams already submitted their programs. Then we'll introduce the detailed rules. There is a QR code and a target in a 3D model of Japanese experiment module Kibo on the simulator. The target represents an air leakage point. The approximate location is known, but the specific coordinates are unknown. Also, there is turbulence around the air leakage point. The keep-out zone represents that Astrobee cannot penetrate the keep-out zone. Any keep-out zone is set randomly out of 8 patterns of shape. So the participants must create the program so that it handles all the patterns. These are the 8 patterns of keep-out zone. The direction to aim the laser will be defined depending on the shape of the keep-out zone. The game starts at the docking station. First, move Astrobee to the point A. And read QR code from the camera image. The location of point A prime can be obtained from the QR code. At the point A prime, air tags is in the camera view. Aim the center of the target using the air tag and irradiate the laser. There is a keep-out zone in front of the target, so it's required to irradiate accurately from the diagonal position. After the laser irradiation, move to the point B. A crew is waiting at the point B. The game is over when the Astrobee reports the mission completion to the crew. Today there is no crew in the simulator. However, in the final round on the ISS, an astronaut will be waiting at the point B, and the time limit is 5 minutes. Scoring is classified into 4 classes. It's based on the mission achievement rate. Class D is no QR code is found. It's given to a team who could not read a QR code. Class C is QR code is found. A team that reads the QR code receives this class. Class B is QR code is found and laser pointing is done. A team that reads QR codes and pointed the laser will be in this class. Class A is QR code is found, laser pointing is done, and mission completion is reported. When you reach Class A, the score is calculated from the accuracy of laser pointing and the elapsed time. In addition, in the programming skills round, 8 simulations are run per each submitted program. These 8 simulations have different conditions such as keep-out zone pattern and the target location. After that, the worst score out of the 8 simulations is used as the score of the team. So all teams are required to get their worst score higher. The most robust program will be the winner of the programming skills round. That's all the explanation of the rules for Kibo-RPC programming skills round. Good luck and enjoy the Kibo-RPC programming skills round.
Wow, very challenging. Okay, long awaited. Now we are going to hold the competition part. Are you ready? We are going to watch simulation videos, 3 countries and regions in alphabetic order at a time. I am so excited about how your programs turn out. I would like to remind you that it is crucial to stabilize the robot's moves in any conditions in space. In this point of view, we run your programs in 8 different cases and compete with their worst cases. The videos will show the worst cases at double speed fast forward, and commentators will explain or give comments on that. Professor Nakasuka and astronaut Yui, I will hand it over to you.
Okay, thank you, Naoko-san. Okay, let me see the screen, please. Okay, so please stop it. And so before going into the simulation, I'd like to explain how you can see this screen. So the screen is split into the 4 parts, and the 3 of them are occupied by the simulation result of the 3 teams. Australia, in this case, Australia, Bangladesh, and Indonesia. And each team's screen, we have 3 pictures. The upper left picture shows the pictures taken, a video taken by the rear camera of the Astrobee. And the upper right shows the video taken by the forward camera of the Astrobee. And the lower side shows the overview of the movement. And the red part indicates the keep out zone. And also the lower screen has several words like checkpoints and so on. So if the QR code is successfully decoded, then yes will appear at the first line. And if the laser light is successfully emitted, and the yes will appear in the second line. And finally, the mission is completed, then the yes will appear in the third line. Okay? So now you understand? Okay, so let's go the simulation. Please start. Now it is moving toward the position of the QR code. Okay, you see?
Okay, looks start turning.
Yes, start turning to see the QR code.
Okay, yeah, almost the same timing, right?
Yes, yes, I think so. Good. Now they are trying to decode the QR tag.
Okay.
QR code. But it takes some time.
It seems easy, but actually difficult, right?
Yes, 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 yes. It requires a certain kind of the image processing.
Okay.
Oh yes, appeared in the first 2 teams. Australia and Bangladesh successfully decoded the QR code.
And Indonesia as well.
Oh yeah. And now they are moving to the next point to find out the very good position. Oh, already the Indonesia emitted the laser light.
And hit the target.
Yes, hit the target. Congratulations.
And Dream Rover as well.
Oh yes, yes, yes. And how about Bangladesh? It is still waiting.
Waiting, yes.
Yeah, they are trying to avoid the keep out zone to achieve a very good position. And then they will. Oh yeah. Oh, it's a very good position. A very good accuracy.
Center, yeah.
After the emitting the laser light, they are trying to go to the point B, the final position, and without avoiding the keep out zone. Yes, the Indonesia obtained the position B. Yes, yes, finish.
A class.
Class A means completion of the task. And the accuracy is 2.94 centimeter. How about the other 2? Bangladesh is approaching the final target, final position.
Yes. It's really smooth.
Yes.
It's really hard to believe this is the worst case for
yes.
each team, right?
Exactly, exactly. Okay, both team achieved.
Okay,
and how is class? Oh, class A. Oh.
Everybody got class A.
Oh my God.
Yeah.
And the laser accuracy seems 1.57 centimeter in the Bangladesh. It is very, very good. Okay, so now let us finish the first 3 teams and move on to the next 3 teams. Please prepare the screen. Okay, let's start.
Started?
Yes, already started. Japan, Malaysia, New Zealand. So Astrobee is approaching the point A to see the QR code and turn around.
Yes, very smooth.
Yes, very smooth. Okay. And Malaysia start decoding the QR code, and Japan and New Zealand too.
Yeah, almost the same, so no difference so far.
Yeah. So each team has its own statistic as a strategy to decode the QR code, because image processing requires very much time.
Okay. So it seems Malaysia already.
Already, yes. Yes appears in the first line.
And Japan.
Oh, Japan also, yes. And they are trying to move to the good position to emit the laser light.
Okay.
By avoiding the keep out zone.
Okay.
How is the New Zealand?
Yeah.
Oh yeah, Japan, emit the laser light.
Okay, and hit the target.
Yes. Good. Now it moved to the point B to report to the astronaut. Come on, New Zealand.
Yeah, it seems it takes time.
It takes time to decode. Malaysia also has some, difficulty to find a good position to emit the laser light.
Of course, time shorter is better, but also accuracy is important, right?
Yes.
So,
it's a kind of the trade-off.
Okay.
Between the accuracy and the time.
Okay. So cosmic jellyfish almost reaching.
Yes. Oh yeah. Now
point B.
It reported.
They have reported to the astronauts.
Maybe it will class A.
Yes.
Yeah.
Okay.
Good. Congratulations. Laser accuracy is 6 centimeter.
Oh,
New Zealand. Finally successfully decoded.
Yeah.
Yes.
This is the worst case, so that is why maybe
Yeah.
a little bit more time.
Yeah. Sometimes just to keep out the zone, location is very, very difficult location.
Okay.
And it makes it very difficult.
So that is why it's really important to have good strategy,
yes,
right?
Yes. That means a robust strategy is very important.
Okay.
Oh, unfortunately, two countries' team didn't complete the mission, so the class C result.
Okay, maybe time's up, right?
Yeah, I think so.
C class.
Okay, so let's move on to the last 3 teams. Please prepare the screen. Okay, start.
Okay.
It moves.
Okay, yes. Also very smooth.
And they turn around. Singapore, Thailand started turning around. Taiwan as well.
Yes.
And in front of the QR code. And they start decoding. Okay, it takes some time.
Okay,
as
so
well.
indentation error already read the QR code.
Oh, yeah, it started moving. Oh, good. Oh,
wow.
Wow.
Almost the center.
Almost the center.
The target.
Oh my gosh. Oh.
Is this really worst case simulation?
Very?
Wow.
Oh, it's already started moving toward the point B.
Wow.
Very fast.
Amazing.
I didn't see any movement from point A to the point A dash.
And it was really accurate.
Yeah.
Bullseye.
Yeah. Very good. Oh, it's complete the mission already.
Wow, that was quick.
Very good.
Oh,
also the Taiwan team made. Oh, also the very good accuracy. And Singapore
Taiwan,
seems a very good accuracy as well. Yeah, after the point A dash, Taiwan teams very quickly moved to point B.
Yes. So each team has different strategy actually, going toward point A or point B. Everything is different.
Yes,
so
yes.
Really interesting to watch.
Oh, yeah. Taiwan team succeeded.
Great.
Oh, Class
Class
A.
A.
Point
Wow,
0.61 centimeter.
Yeah.
Can you believe it?
Oh, wow.
Wow.
And also Singapore team.
Yes,
as
also.
well. So
Yeah, rather
all
good.
Class
5
A.
point.
Amazing.
Class A, amazing. So the 3 teams succeeded and complete the mission. Anyway, congratulations. Okay, so it's very interesting to see the movement of
amazing.
the
Everybody did
program.
great job actually.
Yeah. Okay, so now we finish the 9 teams performance, and so I would like to go back to the Naoka-san. Okay.
Thank you, Professor Nakasuka and Kimiya-san. Well, considering the fact those are the results of the worst case of each team, I think each team did a wonderful job. Now we are going to announce the winners who hold the best programming skills. Kimiya-san, please announce the winners.
Okay. Everybody did a great job, so it's really hard to expect who is the winner actually. So are you ready for the winning ceremony? Okay, so this is the 3rd place. We have an envelope already. Okay, so the 3rd place winner is Enigma Systems, Bangladesh. Congratulations. Great job. I think Bangladesh last year, you guys actually just observed, and this year, first time participation, and you guys did great job, excellent job, and received 3rd place. Congratulations. Okay, so I know that Bangladesh and also Japan has very similar national flags. I feel like Japan and Bangladesh is just like a brother. So hopefully you guys have a chance to travel to Japan and talk about this experience with me. Thank you. So let's move on to the 2nd place. Okay. The 2nd place winner is Gemini, Paraguay, Taiwan, from Taiwan team. Congratulations. Wow, that's great. And I think the score was, I think, which one? 59.28, I think. So that is great.
71.
Oh, 71? Sorry. Oh, 71.77. Okay. So that is really great. And I think you guys are learning in Taiwan, but originally from Paraguay, right? Mm-hmm. And I think JAXA this March, actually released first cubic satellite, Paraguay satellite. So if you are interested in, please develop second one and release from GEM. I'm really looking forward to see your new satellite actually as well. Okay. So I have an envelope which had 1st place. The 1st place goes to Indentation Error from Thailand. Congratulations. Okay. And it was so amazing, so accurate. It was really hard for me to believe it was the worst case scenario, right? Yeah. It was so quick and it was so accurate. So no doubt you guys got a first place. So I'm really interested in, if you're interested in, please work for not only the Thailand, but for Japan as well. And if you're interested in, please work with JAXA and develop new satellite. Okay, thank you very much. Congratulations again for the team from Thailand. And score was, by the way, 88.22. Really high score. Congratulations. So, Tarit-san, the leader of the indentation era, how do you feel? Please explain your feeling right now.
I feel like really great that I won this competition because we spent a lot of time in the past, like 3 months, to develop the program, and the result really paid off that I spent the time to develop my program to make it work really good. Okay. And along the way, I also learned a lot about Java and developing for Android, and also moving in the 0G in the space that we never experienced before.
Okay, great. Thank you very much. So let's watch the video, which is showing the your simulation result. So, Tarit-san, I want you to explain the result of your strategy, and also what place actually worked well and what point actually it didn't work well, actually. I think your program was perfect, but if you have any, please explain good point and also bad point by watching this video. So Tarit-san, please explain.
So here we just undock the Astrobee and move to read the QR code. So in reading QR code, we copy in the image to make it process faster, and we use the C-bar library to decode the QR code. And now we decided to just rotate the robot down to shoot the target and not move down because it will make it faster. And then we move to point B to report the mission complete.
You guys did a great job, and you had really good strategy, actually.
So that's the end of the target.
Okay, wow, amazing. I think everything went well, right? As you expected.
Yes.
Great, great, yeah.
But we tested a lot.
Okay.
Before we reach the final version of the program.
Okay. Again, congratulations. Excellent job. Okay, so now I'm going to hand over to Naoko-san. Thank you.
Thank you, Kimiya-san. And big congratulations to Indentation Error. Now we'd like to hear the closing remarks from our advisor, Professor Shinichi Nakasuka.
Thank you very much. So everyone, congratulations for your excellent performance of your programming. So the design point of this robot programming is how to set the waypoints, including position and attitude. If you put the waypoints near the keep out zone, it becomes risky, but the time will be shorter, of course. So it is a kind of the trade-off relationship. And the target is behind the keep out zone and cannot place Astrobee in front of the target. So you should find out the most appropriate position of the Astrobee at the time of laser emission. Thailand and the Taiwan teams seem to have very similar strategy. after decoding QR code at position A, Astrobee does not change the position, but rotate itself to see the AR tag and the target and emit the laser light from near point A. That is a very, very good strategy. And it is very good skillful tactics as it can reduce the risk to enter keep-out zone and also reduce the time. It is very, very good. So please show the result, total scores, please. Yes, so this is the total scores. So the Thailand, Taiwan has a very, very good achievement. It is very high scores. Okay, and the third, fourth, fifth, sixth, and seventh. So unfortunately, 8th and 9th team did not complete the mission, so the Class C result. As I said before, in this year programming contest, the worst case result was evaluated for ranking. This is because, as the explanation before, in space you should develop systems which can work to a certain level in any circumstances. Thailand and the Taiwan team, the point very high. That means they developed a very, very robust program. Okay, let me add the best score. Okay, please compare these two scores. Best score is the best score among 8 simulations. Okay, and the worst score is the worst score among 8 simulations. So it is very interesting. From 1st to 5th ranking, the team is the same. That means that team which develop a very good program can have a very good result in the best as well as worst. It is very interesting. And also it is amazing that the Thailand team, the difference between the scores, between the best score and worst score is very, very small. Just 1.6 point is very small. That means they develop really robust program. Okay? So this is very, very interesting result. Okay, so today is a simulation competition. So the next step will be the real experiment in ISS, in space. So in space, more and more unexpected things or events may happen, okay, in real environment, which means that your program should be more robust. Okay, please improve your program until the real experiment, and I hope all of your program works well in space. Thank you very much.
Thank you, Professor Nakasuka, for the encouraging closing remarks. I think everyone did a great job. You must have learned a lot. I'm so proud of each of you, and please be proud of yourself. Your challenge will continue to the onboard competition in September. Before we conclude the event, I want to quickly introduce the final round. We will hold the final round in September. We will run Astrobee with your programs, and you will report the completion of the task by pre-recorded voice to astronaut Akihiko Hoshide, who is a commander of the ISS on board. The running order on board is according to the ranking from this programming skills round. As you see on this chart, we divided the teams into 3 tiers. The order of the tier means priority to run Astrobee in orbit at the final round. Also, all the teams have a chance to improve your programs and turn in the upgraded program in August. I'm so excited to be able to see Astrobee moving on board the ISS with your upgraded programs. See you in the final round, and I wish each team all the best. Thank you for joining us, and thank you for your challenges.